Good day, everyone. We are the group 2, and our chosen topic is inverse of a matrix using determinant. My name is Shannon Shashon.
And my name is Charles Yusi, and we are the presenter of Group 2.
Alright, so before we start on the inverse, let's have a brief introduction about matrices. Matrix is a rectangular array of numbers, symbols, or expression arranged in rows and columns. This matrix right here is a 2x2 matrix, which is also a square matrix, which has 2 rows and 2 columns. And now this is an inverse matrix. An inverse matrix is a matrix that when multiplied by the original matrix results in an identity matrix, which consists of ones along the main of diagonals and zeros and everywhere else. So how do we find the inverse matrix of a 2x2 matrix? We can use the determinants, which are mathematical expressions that are used to solve systems of linear equation. This slide will be presented by Mr. Charles.
Okay, thank you, Shan. So on this topic, calculating the determinant. So what is minor? Minor determinants are the determinants of the minors of a matrix, which are the matrices that are obtained by deleting one row and one column from the original matrix. The second one is cofactor. Cofactors are the products of the minors and the signs of the elements in the original matrix. This is the second topic, solving a word problem involving a system of linear equations. These are the three methods. The first method is elimination method. Involves adding or subtracting the equations in the system to eliminate a variable. The second method is Cramer's rule. Involves solving the system by expressing each variable in terms of determinants. The last one is substitution method. Involves replacing one of the variables in one of the equation with an expression for the variable in terms of the other variables. This is the example 1 made by our solver. The given is A is equals to 2, 3, 4, 5. To get that A, simply cross multiply the given, then subtract after multiplying A and D and B and C. After getting the that A, use the inverse formula. Just follow the formula to find the inverse of the matrix. This is the solution that you're going to use, and the final answer is A negative 1 and negative 5 over 2, 3 over 2, 2 and negative 1.
And this is our second example. I'll be taking over. Let's try to solve this second example made by our solver. Let matrix A equal to the element 10, 9, negative 2, negative 3. To solve the inverse of this matrix using the determinants, we must first get the determinants of the given matrix. To solve the determinant, we take the product of the element from top left to bottom right and subtract it with the product of the element from bottom left to top right. In this case, 10 times negative 3 minus negative 2 times 9 is equals to negative 30 minus negative 18, which is equals to negative 12. Then we use the given formula for getting the inverse using determinants. We swap the places of the elements A with the element T, and then we add and negate the signs of B and C. In this case, the matrix becomes negative 3 and negative 9 and 10. Using the formula, we multiply 1 over the determinant, which is negative 1 over 12, to all the elements, negative 3 times negative 1 over 12, which is equals to negative 1 over 4, negative 9 times negative 1 over 12, which is equals to 3 over 4 times negative 1 over 12, which is equal to 1 over 6, and 10 times negative 1 over 12, which is equals to 5 over 6. For our final answer, the inverse of the matrix is A is negative 1 over 4, 3 over 4, negative 1 over 6, and negative 5 over 6. So that's how we solve this problem using the determinants. So for our conclusion, in finding the inverse of a 2x2 matrix using determinant is an efficient way to solve a system of a linear equation. By understanding the definition of a 2x2 matrix, the definition of an inverse of a matrix, and how to calculate the determinant of a 2x2 matrix, we can solve a word problem involving a system of linear equation using any method. So here is the full roster in our group. And I think that's it, right, Sir Charles?
Okay. So, thank you.
Thank you. I hope you guys learned something from this video project, and thank you.